welcome to my channel. Today I will be showing you how to install SU2 CFD software code in Ubuntu distribution system. So let's get started. I have compiled some basic steps required to install SU2 CFD software in Ubuntu system. I will show you here. Okay, so these are the basic Linux commands that should be used to install SU2 if you want to run SU2 in parallel mode. So I will be showing you step by step and let's see what happens. Okay, so I have opened my Linux terminal and the steps guide I have created, I will share it with you in the video. Okay, let's get started. So at first we need to make a new folder in our home directory. So let's see in which directory we are in. We are in our home directory. In my case it's home/shaha, and we need to create a folder named SU2. So we can use mkdir command, mkdir SU2. We can see the directory is created here, SU2. Okay, so we will move inside the directory cd is SU2. Okay, we can check our directory. Yes, we are in SU2 directory. Just clear screen, and we need to clone the original CFD code. And here you can see there is a GCC fluid named GCC, which is the compiler we are going to use. We are going to use the C++ compiler, and we need the GCC version. So I will just copy git clone this code, copy and paste in here. So it will clone the SU2 CFD code from this GitHub directory into our home directory. Inside the folder we have called the folder named SU2. So it is cloning. As you can see, it's cloning. And I should tell you that the installation takes quite a lot of time, so I will be pausing inside time to time to skip the length of so that the length of the video is not so long. Okay, so while it finish, we will move to the GCC fluid directory that we are downloading right now. So let it finish. I think it's almost done. It has downloaded the code, and maybe some unzipping things is going on the background. So after that we will install the we'll export the MPI information so that we can run SU2 in parallel mode. So while it finish, we will move to the directory and export, but be sure that you have the MPI library installed in your system. We can check the MPI library, which is the MPI library we're using in our system. Basically, in Linux distribution system, the OpenMPI is already installed, but to be sure, you need to check which version of MPI or whatever MPI library we are using. So I will show you how to check that. We just need to finish, or you can maybe you can use another command terminal to check. No, maybe not. Okay, let's just wait to finish this resolving deltas things. It takes quite some time, and after the MPI library is exported correctly, then we can build the SU2 library with the GCC compiler. So yeah, it almost finished. It already did the 100%. Okay, so it finished, as you can see. Yes, it finished. Okay, it finished downloading. Let's just check what is it downloaded. CLS. Yeah, we have a folder named SU2 version 8.0.1 GCC fluid. So we will move into the directory cd SU2, press SU2, press tab to autocomplete, and we are now inside the GCC fluid directory. So just before we export the MPI library, before the installation, we need to check which version of MPI we're using, or if MPI library is installed or not. So let's check which MPI execution. So MPI library is installed in our system, and we need to check version, MPI execution version. So yeah, we have the version 4.1.6, so it's installed. So we just continue with the installation steps. You need to check you need to make sure that your MPI library is in the correct location before exporting. So basically, if you have done installation in any Ubuntu system and did not change the installation directory by default, it will be in user/bin/mpicc. So I will just export mpicc, copy and paste, enter. Export mpicx, cxx, sorry, then paste, enter, and some other two comment. I will just copy, enter, copy, paste, and enter. So it has finished the exportation. Now we can build the SU2 CFD software for our system. We need to type mason.py. This is a Python code, sorry. Copy and paste. So what it is actually doing, it is running a Python code to make the Ninja system, Ninja framework for the SU2 CFD installation with the MPI equal to true. That means we are going to use the MPI library for running the CFD code in parallel. So I will just hit enter, and the initialization has started, and it will take some time to finish the building. So I will just pause the video here and continue the video after it finishes the cloning and the other things. Okay, as you can see, the mason.py building has been finished. I'll just ignore, and I will show the logs in here, some things from here. Okay, so these are the things we need in our system to work in SU2. So the mason.py build commands ensures these things. So well, we use the C++ compiler, and from here, as you can see, the version is 8.0.1, and we configured the options, the cgns true, add mpi and the other things. If you want to use the other options of SU2, you need to configure according to their website. That means there are different options, MLP, coolprop, librom, and the other things. So we just ignore, but this here we need to export some comments from here in our bashrc file. So I just copy, and I need to import this in my bashrc file. So I will just go to home, and as you can see, I am using the Oh My Josh theme. So I will press Ctrl S to open the ZSHRC file here, and I will just paste it and make the same opening format. Okay, and save, Ctrl S or save, close. I'll just hide again to press Ctrl H and close it. As you can see here, it says use ninja c build gcc install to compile and install SU2 in your system. So we need ninja c build gcc install, but here there is some option J-J4 or -J4. It says that we are building SU2 in parallel mode. That means in my this PC I have four processor. So I will use all my available cores to build SU2 in parallel mode. So I will just copy and paste. Oops, the dot is missed. Dot ninja c build gcc install j4. But before that, I need to add sudo to give the permission to write everything during the installation process, so that there is no error of any permission. So it will ask me for the password of your Linux user system, of my Linux user system. In your case, you have to put your password for authentication of the sudo command. So in my case, I will just enter my password and hit enter. See, it has started the compiling. and it will take some time, I think. So there are a lot of compilation is going on, so I will just pause again and come back to the video when it finishes. Compilation finished in 8 minutes and 44 seconds in 4 parallel run for core processor. So here you can see the log files that it is completed. I think it is completed properly. Let's check with a sample case run. Just clear. And one thing before we move on to the next step, I want to show you one major thing in SU2 CFD. Okay, so SU2 CFD SRC. So we have installed SU2 CFD in our Linux system, but to run the SU2 CFD we need to use this SU2 CFD C++ file to call in our terminal that we are going to execute this SU2 CFD C++ code. To do that, we need to copy all these directory location, that means all this direction, in whenever we run the SU2 code. To avoid this thing, or to minimize the copy of every time we run the SU2 CFD code and copying this directory, we can add a export command in our bashrc file, so that there is not repeated use of this directory whenever we run SU2. So I will just keep a copy of this location, and I will go to my home directory and press Ctrl H to show the hidden files. Since I am using the ZSHS theme, I will use the ZSHRC file, and if you are normal Ubuntu user, you edit your bashrc file, which is here, the bashrc file, the same thing, and I am using the ZSH theme, so I will edit here, and we will export our command SU2 underscore CFD equal, and the directory we copied. So it is eventually the same in SU2 home and then SU2 CFD SRC. This is the location where our executable SU2 CFD CPP, that means C++, is stored. We'll save, Ctrl S or save, then exit, just again hide with Ctrl H, and I will go to my home directory, clear, and I will source the ZSH file, source.zshrc or source.bashrc. Press enter, and it will check all the settings and configurations are in OK condition. It may take some time. Okay, it will finish. Oh, it took update in my ZSH theme, so okay, just ignore it. And it has finished successfully the installation of SU2 CFD code. Maybe we can find some test case or tutorial. These are the test case, so check if no. We need to copy a tutorial that I have downloaded previously, which is the unsteady Naka 0012. So okay, so after the installation is finished, we can try to run a fast tutorial case for SU2 to check if our parallel installation is okay or not. So I have downloaded the unsteady Naka 0012 case, as I was talking about. So unsteady Naka 0012, you can see the files from the tutorial site, and we are going to navigate to this directory and run the CFG file, that means the configuration file, with the unsteady Naka 0012 mesh file .su2 in .su2 format. So let's move to this directory, cd downloads. I am in my download folder, and here is the unsteady Naka case, cd unsteady Naka 0012, and I can check the files here. There are 3 dot files and the mesh file su2 file .su2 and the CFG file. So to run the SU2 code in parallel mode, we need to run the command mpi run with n and the number of core we want to use, number of processor core we want to use for the calculation. In my case, my workstation has only 4 core, so I will type 4 and then I will type the SU2 CFD, SU2 SU2 CFD, and followed by the CFG file name, which is unsteady, and I will press just tab .cfg and press enter. See, it's running. So our parallel execution is working. So yeah, our code is running. That means the installation is okay and SU2 is running in parallel. You can post process the result by using the ParaView software that we installed previously. So it has completed like 50 iteration already. Maybe it will run around 600 up to 600 iteration. That means more 40 iteration, and we can post process the flow.btu files here installed. So we get, so I can open the ParaView and we can see the output of SU2 calculation in real time. So I will just open in downloads unsteady Naka and the flow.btu. So I will just open one case, click apply, and we will see the velocity distribution. So we can change the color scheme from to rainbow uniform. Click apply, close. You can change it to step to see more clearly. So yeah, the code is running and we are getting a airfoil simulation case from the SU2 installation, successful installation after SU2 successful installation. So that concludes the SU2 installation case. So here you can see the SU2 calculation is finished and all the flow output results are stored here. Before closing the video, before finishing the video, I just want to make sure that you know about which MPI that you are running in your simulation in your system. So you can check by running the command mkdir run version that shows the OpenMPI. That means I am using the OpenMPI parallel code for MPI running of SU2 that I talked previously about checking. And if you do not have installed the MPI library, you can use the command sudo apt install install, then leave OpenMPI maybe in development version and just hit enter, and it will enter the OpenMPI library. Or you can just make a Google search to how to install the OpenMPI library in your system. So thank you for watching. If you like the video and if it is helpful for your case, then don't forget to subscribe. Thank you.